What is GenePattern Notebook? The short answer is that it is the Jupyter gateway to the greater GenePattern ecosystem. GenePattern is a platform for reproducible bioinformatics research. It's a long-established project. The first release was back in 2004, and it's been going strong ever since. That puts it on similar footing to IPython, the parent to Project Jupyter. GenePattern is open source under a BSD-style license. Its repositories have a collection of some 250-ish analytic modules, including some of the most popular methods in genetics, genomics, transcriptomics, and proteomics, as well as general machine learning methods. Our public servers have some 75,000 registered users and usually run in the ballpark of 4,000 analyses each week. You can also download the code and run your own private server, as many organizations do. Finally, I want to note that it's an open platform. There is a repository of community-contributed methods that cover a wide range of bioinformatics techniques, including CRISPR analysis, bisulfite sequencing, flow cytometry, and RNAi screens. And by repping your method in the GenePattern module, it is automatically available in Jupyter through a user-friendly interactive widget. One of the underlying goals is to encapsulate a complete research narrative from its conception to its dissemination. This way you can leverage the best of what Jupyter and GenePattern have to offer, interleaving text, graphics, interactive widgets, visualizations, or other analytic aspects. I first want to take a look at a real-world example of these tools in action. Here you see a screenshot of a fairly typical Jupyter notebook. What it's doing is loading gene expression data from various tumor samples and then performing support vector machine (SVM) analysis to divide those samples into different classes. These classes should align the different tumor types. This is first performed in a set of training data where SVM attempts to find an optimal hyperplane for dividing the samples. It's then given a new set of samples of unknown tumor type. The hope is that it will then be able to predict the type of these samples based on the hyperplane chosen with the training data. Now, if you didn't follow what I just said, that's fine. I'm not going to quiz you later. But I do want to note that SVM is pretty common in machine learning these days, and this particular notebook uses the implementation in the scikit-learn package. Anyway, this example works, but it's also about 70 lines of code. And if we're going to reuse this notebook, that code needs to be maintained. Furthermore, if I'm saving this notebook and sharing it with my less programming-inclined colleagues, it would be a challenge to explain to them how to modify it and use it with their own data, or to set different SVM parameters. Here is another notebook. It's also doing SVM analysis, only it's using one of GenePattern's interactive widgets. Analytically, these two notebooks are identical. That is, they're both performing SVM analysis on the same training data, using the same test data, and will reproducibly yield the same results. In this notebook, however, the SVM analysis is being rendered as an interactive widget. Documentation is available through a graphical menu. And if I share this with my less technically inclined colleagues, it's a lot easier to explain. Just click the upload button, select the data you want to use, and then click run. Even as a programmer, I like to sometimes use these widgets. If nothing else, they help to reduce stupid, albeit time-consuming mistakes I might make in the code. All of this makes for faster and more accessible research. So I keep mentioning that GenePattern Notebook is a suite of Jupyter extensions and libraries, and here is the specific breakdown. These include MBTools, which is our interactive widgets framework, Jupyter WYSIWYG, which is a rich text editor for markdown cells, Notebook Repository, which contains Jupyter Hub sharing and collaboration functionality, and finally the titular GenePattern Notebook package, which includes all of our bioinformatics and machine learning offerings. In my opinion, out of all of the features I just named, the ability to render functions as interactive widgets is the real star of the show, and we call this the UI Builder. It quite literally allows you to take any arbitrary Python function and to render an interface to that function as an interactive web form. Then a user can just fill out the form and click the Run button to execute the function. This means that if you're a programmer, you can write your own code, then, with a single line, use MBTools to render a form-based interface to your method in a manner accessible to users of all levels of technical skill. To install the GenePattern Notebook extensions locally, they've been made available through the pip and conda package managers. If you install the GenePattern-Notebook package, you'll get the entire suite. Alternatively, you could opt to only install the NB Tools or Jupyter WYSIWYG packages. We also have a Docker image with the whole stack set up and available, and that's up on Docker Hub. This container has been built for use either as a single-user Jupyter instance or in a multi-user environment in conjunction with Jupyter Hub and Docker Spawner. Finally, I want to reiterate that this is all open source. We have several GitHub repositories that are publicly available, and anyone is welcome to check them out. We love pull requests. I mean, who doesn't? Documentation is available right in GitHub and linked from each repository's README. Now, stepping back to look at the greater Jupyter ecosystem, there are some great tools and a lot of pretty cool integrations. In particular, we know that real-time collaboration is in the works, and we're keeping an eye on that as it progresses. We're also continuing to port existing extensions to Lab, and look forward to many Jupyter Lab improvements in the near future. Let me just give a few acknowledgements to people who have contributed to GenePattern and to GenePattern Notebook. You can see the team on the left. Jill Mezarov is our PI. And on the right, you can see that we've gotten funding from these wonderful organizations. I would also like to put up a few resources from the net, which you can visit if you want more information. These include the GenePattern Notebook Workspace, our website, our GitHub organization, Docker Hub, etc. So with all that being said, enjoy the convention.